VCF West. I'm very excited to be here. My name is Dan Sanderson. I work on the MEGA65 project. That's what you see on the screen right here. This is a modern recreation of the Commodore 65. I'm going to start with an obligatory audience survey. Raise your hand if you own or have ever owned a Commodore 64 or a dedicated device capable of running Commodore 64 software. Most of the room, thank you. Keep your hand up if you still own such a device. Most of the room, awesome. All right, who here, this is a predictable question, who here has ever owned a Commodore 65 or a device capable of running Commodore 65 software? One, good, two, great, okay. Still own? Excellent, thank you. The MEGA65, of course, is such a device. It can run Commodore 65 software. But I want you to remember that you own these things, right? You are a primary source in the terms of historians, right? You experience these things, you know these things, you have firsthand experience. You're the ones carrying forward the knowledge of what it means to own a Commodore 64, or in a couple of cases, a Commodore 65. So how do we remember computers? And why? Why would we remember computers? There are lots of ways and lots of reasons. The most obvious one is just our childhood memories. These are, for many of us, recent enough that we owned these things when they were popular mainstream devices. We think of childhood memories as being strong impressions, the things that we most remember, but I struggle to remember my own childhood. I only have a few pieces of it, and it's usually the stuff that I'm able to revive those memories through repeated impressions or something like that. I was definitely a Commodore kid, I remember that. I had a Commodore 64, I had a Commodore 64C also. I spent many hours on my computer. That's basically how I spent my time. And when I wasn't allowed to use my computer, because my parents were concerned that I was spending so much time on my computer, I would be out on my bike going to the public library to read books about computers and the Commodore and magazines. And they also had discs. My public library would let you check out discs. It was mostly public domain software on fresh copies of discs because they knew that we would ruin their discs, but it was awesome. You could just check it out. I remember a lot of the details of the environment too. I remember my father's basement, I remember the carpet, I remember the smell. I remember having a record player that I kept on the floor. I got it at a yard sale and I would listen to records while I played with my Commodore 64. These tangible details, largely because I was able to go back to my father's house throughout my later childhood and early adulthood, right? I could go back to that basement and relive some of those memories because the sensation is so strong. The sensations are particularly strong in some of these things, right? We all have this burned into our memories. I remember writing lots of programs as a kid. I remember I would go to the grocery store with my mom, and then I would come back and dash off a quick basic game about grocery shopping or something like that. I really liked character graphics when I learned how to change the letters so that they could be little guys or little brick walls or something like that. That was really powerful to me. It was very palpable. And I remember trying to make a Pac-Man game using character graphics. I don't know if I was fully successful, but I have that vivid memory of what those graphics looked like. I had the Commodore 64 through junior high. I remember BBSs. I remember Quantum Link. I got an Amiga 500. I convinced my parents to get me an Amiga 500, and I used that through high school. My parents didn't have an attic or a basement where I could keep these things. And when I got my first college apartment in Seattle, it was a studio apartment made out of an old hotel, it's like a 1920s hotel or something. So it was a small room, and I felt like I couldn't keep it. I had this massive pile of my Amiga 500, my Commodores, and my discs, and my books, and the ROM kernel manuals, and all this other stuff that I managed to collect throughout my childhood were filling up my closet. And I was too young to realize that I would think of my old discs like a family photo album. It didn't feel like that to me when I was 20 years old. So I found somebody on a Seattle bulletin board who was willing to take it, and he came to my apartment in a green Subaru Outback and loaded everything into his car and drove away. I know, thank you. As an adult, I've wondered if my discs are still out there. Maybe he's a collector, maybe he kept the collection together, maybe I could find that guy. But green Subaru Outbacks are very popular in Seattle. And I'm not sure I could ever identify this guy from 20, 25 years ago. All that's left is what I can remember, and that's not much, like just sort of scattered memories. My most durable memories of childhood are of media, mass media in particular, right? Movies, TV shows, books, magazines. These things were made to be remembered, right? They were vivid, they were mass-produced, they were made to be popular, they were designed to be popular, they were promoted. Much of it, though not all of it, notably not all of it, is captured by a media industry willing to preserve and revive it. We have to capture some of that as archivists to make sure that they're preserving these things and carrying them forward so that we can remember these things. And some of the gaps are made up by home recording. Once we had home recording equipment that we could record things off of TV or just own the VHS recordings or something like that, many of us have those in our homes and can carry those forward that way. A lot of the most potent memories, especially of media, are sound. And so like theme songs, TV theme songs were like really burned into my memory. I don't know if my audio is set up here. Let me try this for a few seconds. It is not set up. You can see it though, right? There you can hear a little bit. Is this doing it for anybody? Yeah? I'm going to cut it off so we don't get a copyright strike on our YouTube video. But you get the idea, right? Like that's the media that sort of burned into us. 3-2-1 Contact was a science show for children. I remember it very fondly. One of many TV shows of the time. Computer software, also a form of media, right? Like we have these things to remember those experiences by. These were also mass-produced and are able to be preserved and carried forward. We can play some of these things on our modern devices today. And I'm sure you can all hear the Skate or Die theme song in your head right now just from seeing the title screen. I played a lot of games as a kid, although I have to admit I mostly just spent time sitting around waiting for them to load. So I spent most of my Commodore time looking at this. Of course, computer magazines, a big part of the media experience. Computes Gazette, I was big on Computes Gazette. It was most of my experience with the computer. I would get it every month. I would mess with the articles. I would struggle to understand it. I was still a little young, actually. I was like 8 or 9 years old for this, but it was, I knew that there was something exciting happening, and I would flip through it and try to make it a part of me. Many of us, I guess I would say that the media itself only captures part of the experience. I think that's really important. Like, we think of a movie and we say, oh, well, the experience of watching the movie is just watching the movie. And so if you preserve the movie, you can recreate that experience anytime just by watching the movie again. But you can't watch the movie in its original cultural context, right? You have to sort of force yourself to think in terms of a 1980s kid when you're watching Back to the Future or something like that. Watching it in a modern day as a modern cultural context, you don't always have these things. So like a magazine, sure, we still have the magazine, but do we still have the experience of type-ins? Like, we can recreate this experience if we sit down and type all this in. I'm not gonna, but we can if you want to. So there's definitely a part of the experience that's not captured directly by the media. There's a practice there that is not captured. And in order to really capture these memories and what these things mean, we have to execute that practice. Commodore 64 sold millions of units. I've heard a bunch of different numbers now. I'm sure everyone in this room has an idea of how many Commodores were sold, somewhere between 12 and 20 million. We have many working units today as a result of it being so popular. I call it a restoration funnel. Like, we take all the existing machines, and as they break or electrostatic discharge pops one of the chips or something, we take another one from a working unit and we sort of consolidate them into fewer and fewer working units. Probably a very long lifespan still for Commodore 64 in particular, because there were so many. And we tend to take that for granted, I think, when we talk about, oh yeah, we should use vintage parts when we're talking about a Commodore. It's tempting to think that we can preserve computer history just by retaining the object, right? This is what it is. It's what you see here. It's its technical specs. It's its technical capabilities. The object is the thing, and if we just have the object, then it's preserved. And computers are seem especially amenable to this interpretation because they're defined so precisely. Like, we think of them as regular, and so we think that, okay, well, if we just put this behind glass, then we will have captured the idea of what a Commodore 64 is. and it will last for as long as it sits behind glass, and we can read about it and try to understand it that way. But computers are defined by the lived experiences of the people that own them. What they did with the computers, what software they ran, what activities they performed. And understanding these requires practicing, learning, and teaching. It's an ongoing process, right? We have to maintain the technical knowledge. That's something particular to preserving computers, right? Is if we don't maintain the technical knowledge, then we lose the ability to run them properly. We lose the ability to maintain them and fix them when they're broken, and so we have to keep teaching people these things. Thankfully, this sort of coattails off of an inherent interest in computers in general. I'm just generally interested in computer architecture and electronics and programming. It just happens to be, I grew up that way, and I think that will be an ongoing interest. And so we can fuel the historical preservation through these sidebar interests of this. It's just generally interesting. But it still takes effort and focus to preserve these things. We have to use these to recreate old experiences. I know lots of people in this hobby where their main recreation is setting up the computer and running old software and just seeing it run, right? I think maybe very few of us actually play the games all the way to the end. I know some of you do. I'm not knocking it. It's a fun entertainment. But just getting the game running is its own game, right? Or Office software. I love vintage Office software. I'm not going to use it. But I love setting it up and running it and getting paperclip running, and it uses a dongle for its copy protection, and how does that work, and so on and so forth, right? So there is a sense of historical recreation in what we're doing. It's a critical piece of the activity to actually relive these experiences and connecting these experiences with a modern context. I think that it's inevitable that we're reseeding it in a modern context. We can try to recreate the circumstances of the original as much as possible, but inevitably we're sitting at a modern desk in a modern home with a modern computer sitting right next to us. We have the internet. I think about how I tell my kids, you never knew a time without broadband internet to the home. And then I think, I certainly had a huge portion of my life where I didn't have broadband internet. I don't actually remember it that well. Like, I can barely remember a time before broadband internet, and I lived a huge part of my life before then. So I have to actively think about what was that like to not have broadband internet. So today's Commodore community doesn't just keep the Commodore 64s on the shelves. They turn them on. We turn them on. We wear them out. We figure out how to replace their parts with modern equivalents or build all new systems that run Commodore 64 software. That is all part of the activity. And that last part is going to get increasingly common as we get fewer and fewer working vintage units, right? We want more people to have these experiences. We want to build new Commodore 64s that can recreate the experience, run the same software. And that brings the full historical definition of what a Commodore 64 is into the present day. But that presents a tension between preserving historical detail and mixing in new ideas, right? When we think of a Ren Fair or something like that, we're still using our credit card to pay for the turkey leg or whatever. We can't escape it, and the more accessible we want to make it, the more attached to modernity it has to be. That's just a tension there, and you can sort of navigate your own way through it as to decide how important each piece of it is for you. But that's what keeps it alive, right? It's a living memory. So even though there's all this media that we preserve like media, computers are not media, they're a medium. We want to preserve the medium by using that medium. And it's much more like preserving a language than preserving a text. You think of Navajo or Hawaiian languages. In order to really preserve them, you can't just write about them in a book. You have to teach them. You have to actually use those languages to keep them alive and have people actively speaking them. So it needs modern day practice. So that brings us to this. This is the Commodore 65. It's a picture that I took off of eBay when somebody was trying to sell one. They tend to sell for about $30,000. So if you want one, the vintage model is going to be hard to get. Commodore was going to make The Commodore 65 is like the last successor to the Commodore 64 on the 128. It was a late 1980s project when it really started coming together, but delays took it into 1990 and then 1991, and then the market opportunity was lost, and they canceled the project. They took it all the way up to the prototype stage. That's what this is. This is a prototype of the Commodore 65. They made, we think, maybe a couple hundred prototypes, and when Commodore went bankrupt in 1994, they liquidated these prototypes in the open market, and that's how we know what this is. That's the only real way we know how this is, other than by oral reports from the people who worked on it. So the Commodore 65 was Commodore 64. They focused on Commodore 64 compatibility. It could run Commodore 64 software. The architecture is really interesting. I don't know if I'm going to have a lot of time to talk about the technical details today, but come talk to me later. I've got a MEGA65 exhibit in the hall where we can talk about the technical details. But it's pretty neat. They could run C64 software and have competitive new features. So those are best described as just in a spec list. The CPU is a successor to the 6502. 6502 evolved to the 65C02, and then there's, you can kind of branch the history from there, but there was meant to be a Commodore-developed, Commodore-owned 65CE02, originally known as the 4502. The 65CE02 was going to be the marketing name for this new processor. It had all the original documented instructions for the 6502, and all those unused opcodes were going to be reused for new instructions. There are quite a few new instructions. I have a mouse pad at my deck table with all the instructions listed if you want to see them. But this also meant, if some of you know some Commodore 64 programming, there are programs that used those unused opcodes, right? The 6502 had behaviors attached to those opcodes, even though they were unofficial. And so this introduced a compatibility issue with some Commodore 64 software, that the 4502, 4510 used those opcodes for other things. It's one of several sort of compatibility restrictions with Commodore 64 software. It had 128K of RAM. This is where it gets a little bit tricky to talk about the Commodore 65. Like, to say it had, well, what is it? Well, the prototypes had 128K of RAM. It was intended to have 128K of RAM. We didn't get a chance to really define this in the popular experience, right? So it was intended to have 128K of RAM, expandable to 8 megabytes. Had a nice beefy ROM, 128 kilobytes of ROM. That included the Commodore 64 ROM, so it could run Commodore 64 software. It had a new generation of the VIC chip, the VIC-2 that we're all familiar with. They had a new version of that with new graphics features, more color, higher resolution, bitplane graphics, a bitplane graphics system. Came with 2 SID audio chips for a total of 6 voices. Had a DMA, which is really cool. I don't think I really knew how to program a DMA until I started messing with the MEGA65. Also a technical detail I won't get into because the MEGA65 does it a little differently, but it's a big deal to be able to copy memory around really quickly in an old computer. And it ran a new version of BASIC. BASIC 10 was written for the Commodore 65 in the Commodore lineage of all the other BASICs. We'll talk about that later. I had a built-in floppy drive. That's what that thing is over there. That's a 1581 compatible floppy drive. It had Commodore 64 peripheral ports. You can see the joystick ports on the side. It had an IEC jack on the back. It had a cartridge port, but it was actually, for some reason, they went with the +4 cartridge port, which is a different size from the Commodore 64 cartridge port. I guess you could use Commodore 64 cartridges with an adapter. That's the idea. They also planned an external drive, the 1565. We know a little bit about that. These prototypes are in the open market, but they never made it to production. A lot of these prototypes are basically representing an unfinished state of the machine. Many of them were not fully functional. Prototypes that are out there all have different versions of things in them, so there isn't even a clear definition of which one is the Commodore 65. The main board, even the DMA chips had different versions or were incomplete in different ways. And few people got to use them, right? Only a few people actually owned them. In the original liquidation, they went to some hobbyists. Those hobbyists took an interest, but then they became collector's items because they were so rare. So we never got a chance to build memories on this definition or explore and elaborate on what it means. There are some cool artifacts beyond just the prototypes, though. I love this text file. This is the C65 manual.txt file. You should look it up. It's a very long text file that describes every aspect of the system. Lots of cool comments in it of like to be determined, not yet finished. in pieces here, but it is actually very complete. I call it unfinished, but it really is only like a few things that needed to be tightened up or finished here or there. We also have the original ROM source code. And they dig it out and play with it and even try to get it to, to assembling state. For the MEGA65 project, we actually had to write a new assembler that conformed with this syntax in order to rebuild the ROM and continue with it. One of the people that got one of the original prototypes was Dr. Paul Gardner-Stephen. He managed to get it as a student, and it was his primary recreational computing platform for 16 years. So he's very familiar with it. Even though there was very little documentation, he spent a lot of time with it, getting to know it, digging it out as an engineering student and playing with it. At some point, for most people that originally owned them, like I said, its collector's value sort of exceeded his ability to maintain the artifact, and he sold it to a collector. But he missed it immediately. He wanted it back. And his way of getting it back was to reinvent, to take what he knew and what he could find out and make a new machine. That was a recreation of these things. The project took a few forms. You can read articles about him talking about the evolution of that project, but ultimately it was his partnership with the Museum of Electronic Games and Art in Germany that solidified the idea that, no, this should be a proper recreation of the Commodore 65. So we're already up to 2014, 2015 is when they sort of made this project official. We're calling this the 10-year anniversary of the beginning of the MEGA65 project, this being about April of 2025. So 2015 is officially when the MEGA65 project started. So the MEGA65 as a recreation of the Commodore 65, plastic case, all new mechanical keyboard, mechanical switch keyboard, so it's a really comfortable typing experience, but very authentic otherwise with the shape of the keyboard and the Commodore keyboard layout. The idea here is to finish what Commodore started. They had a really great idea. It was mostly complete. We needed to just sort of finish it up and get it out to people. And make it open source as much as we could. There were some elements that we can't open source, but this is more than just a development ideology, though. This is a preservation ideology. It says that if we can release as much of this project as open source as possible, then even if we vanish off the face of the earth, somebody else could pick it up and keep carrying it forward. So the FPGA core and some other aspects of it are all up on GitHub. You can download them, you can build them yourself, you can clone it, you can recreate it. I did mention it's got an FPGA-based internals. I know some people have sort of mixed feelings about FPGAs, but they are an inevitability in what we're trying to accomplish, right? We need to be able to recreate chipsets, and the only good way to do that is with an FPGA, especially at small scale. But one of the advantages of this is that it's upgradable. Like, you have a unit at home, you can put new stuff in it. You can upgrade the core, you can get new versions of it, you can participate in the development of the machine, you can make your own machine. There are lots of things you can do with the FPGA. So like, once you have one, you actually have all future versions of it as well, in a very meaningful and important way. It does have some modern hardware conveniences. Again, that's sort of essential to recontextualizing this in a way that people can actually use. You need to be able to connect it to a modern HDMI display, things like that. And we do use the licensed C65 ROM. We also distribute GEOS with it. There's a version of GEOS for the MEGA65. We'll talk a little bit more about the ROM later, but that's an essential part of connecting it to the Commodore lineage. If I were to put up a similar spec sheet for the MEGA65, you'll notice that there are some differences. And it's one of those things where you give engineers an opportunity to work on something like that, and they can't resist adding a few more things. I consider that to be part of the recontextualization process. We can talk about that too, but like, if you see here, like, the original CPU could run at 1 megahertz to run Commodore 64 software. It had a native 3.4 3.54 megahertz mode. We added a 40 megahertz mode. This actually is a huge boon to the thing. If you want to see how cool this is, writing BASIC in 40 megahertz is like a whole new experience. You can do so many new things just with the same basic language just because it's running faster. We bundle 384 kilobytes of RAM plus an extra 8 megabytes of RAM that we call attic RAM, which is useful for some programs. We went one more generation with the VIC chip. We added some video features, so we call ours the VIC-4. Because we could, we added 4 SID chips instead of 2. We also have a couple of other sound features for digital audio and other stuff like that. We've extended the DMA. It can do some extra cool stuff like graphics drawing, things like that. We also call our BASIC 65. I'll talk about this a little bit more in a second as well, but it's another one of those things, you've got your hands on the ROM, you can't resist thinking about, well, what else could this be? And it does have the built-in 3.5-inch floppy drive as well, 1581 compatible. So yeah, just a little back view here, the plastic case, the key switches, HDMI and VGA out, stereo audio, so you can do cool stuff with that, modern power supply, obviously, peripheral ports. We do use SD cards for storage, both an internal one so that you can pretend it's just like a hard drive, a built-in hard drive, or an external one if you want to mess with it. We do now have, through that Ethernet jack, we do file transfer, so you can really just leave the SD card in the machine and manage all your files that way. Just connect a modern computer to it over the network and copy files back and forth. It'll run virtual disk images, which is the way most people use it. Like, there are a lot of people that like to play with the floppy drive, but we only have so many floppy disks, so I think a lot of people just say, oh yeah, I'm going to use the virtual disk images that are stored on the SD card and recreate that experience. It does have the serial port if you want to connect vintage drives to it, though. And we went with a Commodore 64 style cartridge port, so you don't need an adapter to run Commodore 64 cartridges. We even have a data format for MEGA65 cartridges if anybody wants to make one. We haven't done that beyond a couple of test cases, but there's some potential there. The way Paul describes this is he wanted to recreate the Christmas morning experience of having a new machine, right? Many of us are familiar with the Commodore 64, and this is an opportunity for there to be, it's the same lineage, it still feels like a Commodore, but there's a newness to it that's rooted in history. It's based on the Commodore 65, but there's a lot new to explore for most people that are going to pick this up. It's like getting a new machine in 1991 or 1989. A little bit about me real quick. I've been an owner since May 2022. That's when we first started shipping the production units. I'm a member of the MEGA65 steering committee. I'm leading the manual and the ROM projects. I maintain the ROM code, which is a hoot. I love it. I love working with vintage Commodore code. It's amazing. And trying to figure out how it works and also how to amend it and fix bugs and search through it and stuff. I've never written more assembly language code in my life. It's great. I consider the manual and the ROM to be sort of partner projects. My main interest in this is making sure that it's a well-documented platform so that people can build on it, because that's what we want, right? It's going back to that idea of having people generate their own experiences with the machine. They need something stable and well-documented to build on, new games, new programs, new experiments, a lot. I also write a monthly newsletter. I've been writing this newsletter monthly for 3 years. There are quite a few issues out there. You can get it by email and RSS. I do hope you subscribe. This is a great way to learn about the MEGA65, both the community activity and I write feature articles as well for how to program it and sort of details, historical details and things like that. It's kind of a blog about programming to a certain extent. I do a read aloud podcast. My friend Eric here talked me into doing an audio version, so if you actually would like this read to you by me in my own voice, I'm happy to do so. Just subscribe where you get your podcasts. I'm going to show some screenshots. I'll spin through them real quick so we can save some time for discussion. But this is the home screen. Very familiar ready prompt. I can't understate how much I love the Commodore screen editor. It's one of those things that like feels sort of clunky and backwards, but if you think of like the original idea of BASIC as being a programming language that has both a direct mode and a programming mode, where you could take any basic command and just type it in and see what it does in the immediate context. That immediate feedback is so critical and so missing from so many modern languages. I'm a big Python guy, obviously. That's one of the reasons I like Python as well. But the screen editor is sort of brilliant reinterpretation of that idea, right? Because the screen editor doesn't just have a direct mode for entering commands and programs, but you can like draw stuff on the screen. You can move the cursor around and you can play with the PETSCII codes just by typing them and see what they do. And then you can just type the same keystrokes into a print statement, and then it does it programmatically. So it's like the same idea, but then you have full control of this graphic screen. It's very interactive, very immediate. Anyway, there's a little digression there. I get too excited about that. You can see some examples of people being able to use more of the full color modes here. This is the title screen to a game called Showdown by Badger Punch Games. Here's another title screen. This was for a text adventure game. This is available on many platforms, actually, but many vintage platforms. But it is also available on the MEGA65. In fact, you can buy both of these in boxes if you like that part of the experience, right? You know, so if we're going to live action role play the experience of buying box software, that's something we all like to do, I think, and you can certainly do that with these titles. This is a screenshot. My friend Colin is making this game called First Shot. That's not out yet. I think it'll come out this year, I hope. I'm going to twist his arm until he gets it fully released. This is an older screenshot, I should point out. I didn't have time to catch a fresh one. There is a much nicer one. But I think it shows off some of the graphics capabilities really well. You can get lots of different movable graphics objects on the screen with the newer MEGA65 features. So plenty of games being made. People just love writing games for this. It's great for BASIC. It's great for porting and upgrading existing Commodore 64 games because of that sort of scaling architecture, the way it scales up from C64 mode to C65 mode. It's easy to take existing code base and make something new out of it. Demos, people like making demos. Sometimes they're just little experiments. Sometimes they're full-fledged demos with original music and a bunch of animation. We love making tools. I think a lot of engineers show up in this space and say, okay, well, the first thing I'm going to do is write an editor or an assembler or a programming language or something like that. I'm guilty of this. I wrote an assembler myself last year. I think we've got 2 or 3 full-fledged assemblers now and a couple more that people are working on. So we'll have plenty of on-device assemblers by the end of this year, I think. Character editors, graphics editors, people are making. We have lots of great documentation. We have this really amazing user's guide that we ship with the machine. We bundle it. It's wire bound, 250 pages, full basic reference, full color. Come check it out at the table. I've got several copies there. You can flip through and see how nice it is. It's a great introduction to the machine, and it's a very popular thing. People love it. But this is only a fraction of our documentation. The 250 printed pages is part of a doc set that's over 2,000 pages long. And we're not ready to print the whole thing yet. It's still in pretty rough shape, but we're still working on it. There's a lot to document and capture here. It's a little tricky because, as I say, the ideal MEGA65 documentation is a superset of the ideal Commodore 64 documentation. So if you can imagine like fully documenting the Commodore 64 and then also adding extra documentation for the MEGA65, it's quite a project. We have an emulator, so if you are not ready to buy one for yourself, you can run it for free on your own computer and PC, and a lot of people just do this. They just develop software for the MEGA65 using the emulator alone. I want to talk about the ROM a little bit specifically. As you can see some of the code in the background there. The ROM is what powers the whole thing. It's the kernel. I would say it includes the kernel and the screen editor and the basic programming language, disk routines, things like that are part of the kernel. And we started with Commodore 65 code. We licensed it so we can use it, written 100% in assembly language. It's been a huge effort over multiple years by multiple people to fix it and finish it and extend it, right, to make it attractive to people who are getting started with this hobby. Just so much effort has gone into it. This includes, especially now that we have lots of people using the machine, it includes API management, which is not something that we're used to thinking of when it comes to vintage platforms, right? To say, okay, the API is being developed at the same time as people are using it, so you have to be careful about testing and documentation, developer outreach, community management. The ROM contains, ahead of the Commodore 65 ROM, over 600 fixes and improvements, over 300 releases. And we're still working on it. I would say that, I mean, we're converging a little bit on what you could consider a feature-complete endpoint. I don't think anybody really wants us to keep adding features to it and have it just be this sort of ongoing thing where it becomes less and less like a Commodore and more like just a modern machine. But we are allowing for some variance for the short term because we want to still be able to fix bugs. We're still finding like the occasional bug here or there, and we don't want to completely freeze that bug into the system by ceasing development. So we do encourage people to use documented APIs as they're writing programs for it, that kind of thing. It's part of a lineage. If you just think about BASIC, on its own for a minute, the various machines use different versions of the BASIC that added features. Some of them took away features. Some of the features are specific to the platforms they were written for, obviously. BASIC 7 does have some things that are particular to the Commodore 128. BASIC 10 was intended for the Commodore 65, and for the MEGA65, we call ours BASIC 65. But keeping it in this lineage is really important to us because we're trying to keep it connected to Commodore. We're trying to keep that Commodore feel, right? We want to use PETSCI, right? We want to use the PETSCI font that I'm extremely fond of. I have an intimate familiarity with. This always reminds me of the Commodore whenever I see it, even in this sort of new context with 80 columns and full color and stuff like that. It's still PETSCI, and it's still recognizably PETSCI, right? But when we think about it this way, like what is a Commodore 65, as I've sort of been saying, is difficult to pin down, right? It was an unfinished implementation to begin with, unfinished, if you allow me that. So the prototypes are diverse, so you can't just pick like one prototype and say, that's the Commodore 65, we're going to emulate that one. So there's a lack of access to the actual reference point. Even if we wanted to pick a prototype, getting a hold of a prototype is really hard to like fully clone it and all that other stuff. We actually had to compile a lot of our knowledge about the Commodore 65 from varying sources without having direct access to a Commodore 65. And there's limited historical memory to work from because so few people had them, right? The fact that Paul put so much of his time and effort into studying the Commodore 65, that's like our primary source of historical knowledge. Like he knows that machine really well and he was able to carry that forward into the project. There's a practical concern about historical accuracy, right? There are some people that wanted us to stop, fussing with it, stop adding things to it. It should really just be a recreation of the Commodore 65, whatever the Commodore 65 is. But the practical concern is that there are lots of different levels and kinds of interest in a project like this. Some people are like super hardcore and want it to be exactly historical accurate. Some people are just kind of interested in computer architecture and operating system design and what would it be like to add a few features to the BASIC and stuff like that. And we needed contributors, and so encouraging people to get involved any way they felt like was really important. I think that's an important part of it, right? That's not something that we could have done without. But moreover, it's a way of welcoming a larger community of people. There are a lot of the people who play with the MEGA65 are mostly using BASIC to do so. I prefer assembly language myself, but BASIC is very, very popular, and it's very easy to use, very accessible. And there are lots of people that want the BASIC to have more features. It would be easier for them to use if it just had a few more things that would make it a little bit less Commodore, but much more convenient. And those are legitimate interests, and so we want to accommodate some of those things. And so the community management around this is kind of, by necessity, involving all of those things, because otherwise we're just sort of making something for a hardcore audience. And it's not going to be large enough, right? We need to find a guiding light for the product direction, to keep it have a definition that we can all recognize, but it is an evolving platform and as a way of integrating it into the modern context. So if you imagine, you have Commodore DNA, and it's a little bit incomplete. We have most of the DNA, but there are like these little bits in it that need to be, filled in somewhere with like a little bit of modern DNA, right? And so we go in and we patch it in to have a successful organism, right? That organism being the machine itself, the ecosystem around it, the community. It needs a complete successful organism to evolve and develop. And so like in this framework of thought, we have to sell thousands of computers to get this to our goal, right? To preserve this computer, to remember the Commodore 65, we need thousands of people to have one. And to do that, we need it to be accessible to people and of interest to people. And so, patching in the DNA, completing the idea is the important part, and not necessarily just giving everybody a broken prototype, something that works like a broken prototype. So there's this tension between precise replication of the prototype and building a recreational computing platform with wide appeal. So that brings me to this FPGA part of it. As I said, this is sort of a practical necessity. We can't print our own chips. We can't, make a 4510 CPU ASIC, at least not at the small scale that we're working at. So we use an FPGA, field programmable gate array. It's a programmable chip that can replicate other chipsets. Our chipset has the CPU in it, the VIC-4, the SID chips, device controllers and stuff. We write it in VHDL and Verilog. We do add some features here. We call it sort of hardware acceleration as an idea. I'll just use one example from this slide. The keyboard scanner is something that, when I first turned on the MEGA65, it felt very vintage to me. It was a very familiar typing experience because it was using the same keyboard scanning logic as a Commodore 64. It was all written in the kernel software. And so it didn't matter how great our mechanical keyboard was, it was still possible to confuse the cursor by typing too fast or typing the wrong keys and the wrong combinations and stuff. And it was like the exact same combinations as I remember from childhood. It was kind of a nostalgic experience that I kept making the same typing mistakes. But we didn't feel like that was really sufficient for this. Like, we should just make this better. And so we use the FPGA to give it a few more hardware features. If you can imagine, you can sort of snap your fingers and have a little bit of a more processing logic at the FPGA layer to solve some of these timing problems or something like that. It's worth doing because it makes it a better experience. We were having the same issue with the IEC serial port running at 40 megahertz CPU. It's a little tricky. It's a technical detail. But here we can get to our guiding light, right? Because we need to be able to add new features to it, but what we can do is we use a principle that says we are not going to add anything to the machine that wouldn't be era appropriate. We're not going to add a fancy modern GPU-style graphics pipeline or something like that. It has to be something that would have existed in the early 1990s. And so a lot of our extra features are along those lines. But another part of our guiding light is that we can run the original prototype ROM. So we have our chipset, that's our modern chipset, it's sort of a complete version of what it is, but at any moment you can just switch to the original ROM that Commodore actually made. It's part of the historical archive, and you can see the incomplete BASIC and the other stuff. You can run it directly. This is BASIC 10, right? This is copyright 1991 Commodore Electronics Limited. It was part of their dev kit that came with it, and you can just run it directly and play with it. So this is like, it helps resolve that tension between historical precision and more modern interests. As long as we keep supporting the ability to run the ROM, we can naturally evolve and complete the hardware and also offer a more complete, more alternate ROM. So you can always use a MEGA65 to LARP using a C65 if you want. The FPGA offers a few extra opportunities here because we can completely replace the chipset with anything we want. So if you want a fully functional Commodore 64 with the support of those undocumented CPU opcodes, we have a core for that. This is actually based on, I have to acknowledge, a very rich and vibrant community of people developing vintage computer cores for the MR project. That's where a lot of this work comes from. They are deeply committed to historical preservation of these things, right? So high accuracy of the emulation, the ability to run as much software as possible and replicate as many features as possible. There's a way to port MR cores to the MEGA65, and so this is especially compelling to me because the MEGA65 can become a museum of Commodore 8-bit computers, especially with that keyboard layout. Right, we've all had the experience of running an emulator and then having to use a PC keyboard with it and not really getting the exact same experience. The MEGA65 has a Commodore keyboard layout that works really well with Commodore computers. And so we have the Commodore 65, we have the Commodore 64, we have a PET core, we have a VIC-20 core. All of those are already available. I can't wait to someday have a +4 core or a C128 core. I would love to work on that project someday. I just don't have the time. We have other cores also. The ZX Spectrum you can run on the MEGA65 if you want to. Somebody made a really great TI-99/4A core. And you can find all of this on cores.mega65.org. We had to dedicate a whole part of the website to that. There are even arcade games that you can play. I won't go through this too much, but porting arcade cores is pretty fun too. Getting like really vintage, highly accurate Galaga running on this machine is pretty fun. I already introduced the newsletter a little bit, but I have these really cool animated slides that I use for this, so I'll include them real quick. It's for community news, project announcements. Like I said, I do feature articles, so if you want to learn to program or something. I try to make it highly interactive. This is part of the project, right, is to get people to use it and encourage people to learn about it. And so the newsletters are like, these are some things you can try. Even if you bought this thing and you don't have time to learn it or mess with it, and you only have a few minutes a week or something like that, this is an opportunity to turn it back on for 15 minutes, try some things, learn a couple of stuff, and then turn it back off again and get back to your life if you have to. I'm over 36 issues, like 150,000 words, something like that. I mentioned the podcast and the email RSS. New as of last month, I am now syndicating the newsletter in the new Computes Gazette, if you've heard of this new project, to publish a new magazine under the Computes Gazette moniker. I have a column, so you can also read it there in magazine form if you want to. It's about pumping energy into the community, right? I just want everyone to have a good time, and I know that there's a sort of period of time we have to get over where people are still learning how to get the machine and use the machine. So the Commodore 64 is being actively remembered by all of us, both in our actual memories and our ability to recreate those experiences and those memories with vintage hardware and new hardware that runs like the vintage hardware. It's not just as a fading childhood memory, but as a living, thriving platform with an active community. Thanks to the MEGA65, we can remember the Commodore 65 in the same way, creating new experiences with deep heritage in computing history. I want to close real quick. I want to share the earliest piece of software that I've written that I was able to find. I was never able to find that guy with the green Subaru Outback, but I was able to recover one program because it was published in 321 Contact Magazine, June of 1988. It's a program about grocery shopping, and you can find this on archive.org of all places. Come find my booth. Try the MEGA65. If you like it, buy one. Thank you very much.